The table below shows some common gases and their particulars. So we've got a gas, the relative molecular formula mass, and the vapor density: ammonia, carbon dioxide, carbon monoxide, helium, and nitrogen. And then this paper was from the 2019 science paper 2 for internal candidates. So we have been given some gases here, and their relative molecular formula mass and the vapor density. For ammonia, the relative molecular formula mass was 17, then the vapor density was 8.1, carbon dioxide 4422, and so on and so forth. And the questions were A, B, C, and D. Those are the questions we had. And question A1 reads the gas that diffuses fastest. So choose from the list given the gases that best suits the following descriptions. A gas may be chosen once, more than once, or not at all. The gas that diffuses fastest. So what should we look at in this question? You need to think about what concept, what theory basically are we talking about in this question, or what they're trying to find out from you, what you know. So this will basically fall on matter. We're talking about the kinetic theory of matter. We're also talking about the diffusion, because of course this is about diffuses fastest. So if you don't understand those concepts, it will be difficult for you to answer such questions. So first of all, you need to understand those concepts and how those concepts actually, how they work and everything included. Then you'll be well and good to answer such questions, and they'll be easy to you. So you have to know that from the concepts, that when you have a gas that has got a less relative formula mass, it diffuses fastest. So in the previous lessons, we've been talking about the kinetic theory of matter, and in the lesson that we just posted, we also talked about diffusion and the factors that affect the rate of diffusion. So the diffusion of a gas can be affected by several factors, and we define what diffusion is. So the factors that would affect the rate of diffusion, we talked about temperature, we talked about mass, and we talked about concentration and all those things. So this is basically what the question is trying to figure out if we understand. If you look here, we've got the relative formula mass and we've got the vapor density. So according to what we learned in the lesson, is that the gas with a smaller relative formula mass, or size of the particle, if it's smaller, then that gas will diffuse fastest. So in this question, the gas that will diffuse fastest is the one which has got a smaller relative molecular formula mass. So what is a relative molecular formula mass anyway? So relative molecular formula mass is the same as the relative atomic mass, and the only difference that this one is for ions. If you do not know what ions are, I'm sure we talked a little bit when we introduced them in the lesson for matter. So ions, basically for now, you can just think of something which looks like, which is alternative to an atom. It's a particle which is just like an atom, but with charges. So that's an ion. So you know what an atom is. So an atom has got a relative atomic mass, and an ion has got a relative molecular formula mass. And these have the masses for relative atomic masses. The relative atomic masses for different elements are actually included in your periodic table, so there's no need actually for you to start calculating them. They are already there on the periodic table. So let's go on and answer the first question, having said all that. A1, the gases that diffuse fastest, or the gas that diffuse fastest, will be the one with the lesser relative molecular formula mass and vapor density. And therefore right away see that helium qualifies here. Helium has got 4, 2, the rest have got 44, 28, 20, 28, 17, and you can see that the smaller one here, or the one which is not heavy, is helium. So helium will diffuse the fastest. So here we're going to put helium. That is our gas that will diffuse the fastest. Let's jump to the next question. The name of the gas that diffuse at the same rate. So which gases that will diffuse at the same rate? So again, we just look at those which have similar relative formula masses as well as vapor density. So which ones are those? So we can see carbon dioxide and nitrogen are on the same vapor density as well as relative formula masses. So we basically expect these to diffuse at the same rate. We have carbon dioxide, carbon monoxide, and nitrogen. So definitely it's carbon monoxide. I must have said carbon dioxide. So it's carbon monoxide and nitrogen. Carbon monoxide and nitrogen. So carbon monoxide is 28, nitrogen is 28. So avoid such mistakes in the exam. B, state the name of the gas that will diffuse faster than any other gas shown in the table. So which gas will diffuse faster than any other gas shown in the table? So the question will be, which gas has got a much smaller relative molecular formula mass compared to any gas we have here? So we have to think of a gas that hasn't been included and has got a smaller vapor density in formula mass. So for that, fortunately, you're provided with a periodic table. So you check on the periodic table and see if there's a gas which has got a smaller relative formula mass, and this is our periodic table is given to us. So when we look at this table, we can see that we have got a gas. Hydrogen has got 1, helium has got 2. So hydrogen definitely will qualify to be the fastest here compared to helium, compared to ammonia, carbon monoxide and dioxide, as well as nitrogen. So gas will be hydrogen. So hydrogen will be the name of the gas. What is the relationship between relative molecular mass of a gas and its vapor density? So what is the relationship between relative molecular mass of a gas and its vapor density? So we go back to a table and we see the relative molecular formula mass and the vapor density. So let's start with the one, let's go in order from the biggest to the smallest. Let's start with the carbon dioxide has got the highest relative molecular formula mass, 44. Vapor density is 22. Next, carbon monoxide 28, 14. Then next, ammonia 17, 8.5. So already you can see that the higher the relative molecular mass, the vapor density has to also increase, and the smaller relative formula mass, the vapor density also decreases. So if you have a bigger number here, you have a smaller number there. So there's some kind of a relationship. So when we look at our table, we can see that the vapor density is equals to when we multiply it by 2, we get the relative molecular formula mass. For example, we got 2 times 2, we get 4. 14 times 2, we get 28. So 22 times 2, we get 44. So there is a relationship whereby the vapor density is equals to half of the relative molecular formula mass, or the formula mass is equal to twice the vapor density. So this will be the relationship. So that is the relationship in what we have. So the vapor density is equals to molecular weight divided by 2, or molecular mass is equals to 2 times the vapor density, as we can see from this table here. Under what conditions would carbon dioxide diffuse faster than ammonia, both of equal volume? So under what conditions would carbon dioxide diffuse faster than ammonia, both of equal volume? So when we look at ammonia, in carbon dioxide. So ammonia is relatively less compared to carbon dioxide, because carbon dioxide has got a higher formula mass. So we expect ammonia to diffuse faster, but what would make carbon dioxide diffuse faster? They are the factors that affect rate of diffusion that we talked about, which might include temperature, and how that would affect. We can say carbon dioxide will diffuse faster under high temperature because it have more kinetic energy. If the container for carbon dioxide has got a higher temperature then compared to ammonia, then that will diffuse it will diffuse faster. So we'll specify the carbon dioxide container has to have a higher temperature than ammonia for it to diffuse at a faster rate, because the kinetic energy of the particles will increase, and as a result the diffusion rate will also increase. That is for carbon dioxide if the temperature of the container is higher compared to that of ammonia gas. So that is how I would answer these questions. So in conclusion, it's all about understanding the relative the kinetic theory of matter, the movement of gases, the factors that affect the rate of diffusion, and also knowing what relative molecular formula mass and the vapor density is. And the good thing to take away in this lesson is that now we have an understanding of a relationship between vapor density and molecular mass. So you might just do well to keep this formula for future references. 2 times vapor density times 2 is equals to the molecular weight or relative molecular mass.